for problem number 7, I could already see that, and by the way, this is x approaching -1. We're trying to find for part A the limit as x approaches -1 of f of x analytically. And when I replace x with -1, we get 0 over 0, which means factoring, canceling, and we get a reduced version of that fraction, and we get x plus 1 over x minus 1. And when we replace x with -1, we get 0 over -2, so we just get 0. So there's our limit as x approaches -1. And then we're defining g of x as the function x plus 1 over x minus 1. And what is the relationship between f and g? Well, g of x and f of x are exactly the same, except that in f of x, x is not allowed to equal -1. So the domain of g of x is all real numbers x, such that x cannot equal 1. Okay, so this is important to kind of clarify. And the domain of f of x would be all real numbers x, such that x cannot equal -1 or 1. Okay, because we reduced the fraction originally. Original fraction was up here, so that's f of x, and you're not allowed to replace x with 1 or -1. Just because we cancel the factors doesn't mean we're now allowed to just replace x with -1 here, because we would see here f of -1 would be 0. Well, the limit is 0, meaning there's a hole there, but you're still not allowed to replace x with -1 and get an output. So again, no output for -1 or 1, and for g of x, it's already the reduced version, so there's no hole in the graph of g of x, there's only a vertical asymptote, and then there's a hole in the graph of f of x. Okay, so I hope that makes sense. Now I'm looking at this, explain why the limit as x approaches 1 of f of x is infinity. So that looks like 1 from the right. So I'm really sorry about the poor quality of this copy, but we're trying to figure out here, or show that the limit as x approaches 1 from the right of f of x is equal to infinity. So we're showing that, and so to show that, we'll just find the limit. So we're replacing f of x with the reduced version of f of x, because we can do that when we're calculating a limit. And when we replace x with 1 from the right, we get 2 upstairs, and we get 0 downstairs, and 1 from the right, meaning we are approaching 1 from values that are bigger than 1. And when we replace x with values bigger than 1, 2, 1.1, 1.01, 1.0, we can see that the denominator will be positive, and so we would get positive infinity. And we would say check. And that's it.